Now, the topic under the discussion today, we are going to discuss about the agreement protocol, because we know that in distributed system, we have different processors belonging to the different sites, and all the processors, all the sites are willing to compete with itself to find out the resources and the others. So there is a competition among them, as well as they have the cooperation, so that the ultimate aim of all the sites or the processors is to reach to achieve a common objective. So there must be a mutual agreement which has to be done in between the systems as well as the sites or the processors, so that they can work together mutually. So all the sites, if you talk about the database system, we have in distributed database system, we have different sites, and they must be agree on a certain point that whether they want to go with the commit, or they want to abort the transaction. They want to commit the transaction or they want to abort the transaction. So this agreement typically requires that the sites must have the information, the knowledge about the values which the other sites are having. So meaning thereby, if we talk about the distributed system, we have a distributed commit, because and in distributed commit, a site must know what will be the outcome of the local commit at the different sites. So if the system is free from failure, if there is no failure, then agreement can be very easily done in between the processors. They can come on to an agreement. Uh, Agreement may be in communicating, and how this agreement is being done, it is by communicating their values to each other. And after communicating those values, they will be taking either the majority or a minimum or a maximum, or means there will be some common consensus on the agreement of those values. But when the system is uh, uh, prone to the failure, then this kind of method is not going to work, because the the processors who are going to be fault, or called the faulty processors, they will be sending the conflicting values to the processors, and thus they are going to prevent them from reaching any kind of agreement. So in the presence of the fault, the processor should exchange certain values, and these values which are being exchanged between the different processors, one is sending the value, then the relay of that value is received from the other processors, and this process has to be done several times. So the processor which is going to refine its values, depending upon that, it is going to learn the values from the other processors. This entire process of reaching on a particular agreement is called an agreement protocol. So in this particular case, the failure, as far as the failure of the system is concerned, there may be failure of the processor, there may be failure of the communication channel. So right now we are focusing only on the protocol, agreement protocol for the distributed system, in which the processors are going to fail, or there is a processor failure. So what happens when the processor is going to fail? The faulty processor may be sending some kind of messages to the other processors, uh, which may so as far as general model of the fault is concerned or assumed in this particular case, we are talking about the faulty processors, and the faulty processors may be sending some uh, stupid messages to the other processor. It may be lying on the messages. It may be possible that it may not be able to respond to the message correctly. So uh, all the non-faulty processors which are available in the system, uh, they should know that which processor is going to become faulty. So as far as the agreement problem is concerned, the non-faulty processors in the distributed system should be able to reach on a common agreement, and even if the certain component of the system is going to become faulty. So whatever is the agreement is achieved through an agreement protocol that involves several rounds of the messages, exchange of the messages, which is done among the processors. So we have a certain system model for the agreement protocol, and this agreement model is required to be studied. And we have this model. The first point of this is that if there are n processors in the system, then at most m of them can be faulty. The second point is the processor can directly communicate with the other processors through the message. So it means the system is fully connected. A receiver processor always know the identity of the sender. Means the authentication is always there. That the receiver process is going to receive any message, it must know that which sender has sent that, which sender processor has sent that. And the communication system should be reliable because we are focusing only on the processor failure. So it is assumed that the communication system is reliable. So for simplicity, what we are going to do, we are going to assume the agreement which is to be reached in between the processors, and those values on which they are going to be agreement, that is 0 and 1. So 0 and 1 are the two values which is being taken as far as the agreement is concerned. Now, previously, we have the solution of the agreement problem, which is assumed that the processor could be, if the only processor is going to be faulty and the communication link is not going to fail, then the limiting the fault solely to the processor simplifies the solution of the agreement problem. So before we are going to discuss the agreement protocol, let us first discuss about the synchronous versus asynchronous computation. Now, as far as the in synchronous computation, it is the process in the system runs in a very stepped manner, where in each step the process is going to receive the message, which is sent by the previous processor, performs the computation, and then after performing the computation, it sends the message to the other processor, which is being received in the next step. So everything which is happening, it is happening in a certain steps. So this steps which are used to happen in the synchronous computation is referred to as the round. And a message delay or a slow process can be slow down the entire system of the computation. Now, as far as the asynchronous computation is concerned, the computation of the process does not follow any kind of the step, meaning there it can send it whenever it is being received, and whatever computation is being done, it is done. It is done. All these three operations are being done at any time. And what is in the synchronous case? The first of all sending, then computation. First of all receiving, then computation, and then sending. So it means the synchronous is a kind of a process. Computation is a kind of a process in which everything is sequentially done. But in asynchronous, the things are not done sequentially. So we are focusing here in the synchronous model of the computation as far as the discussion of the agreement protocol is concerned. And because it is very critical as far as the agreement protocol is concerned. Now, the way by which the processors are going to fail. Now, as far as the agreement problem is concerned, as we are discussing the agreement problem just because of the processors are going to failure, we are not talking about the failure of the other things. As far as processor can failure in three modes: crash fault, omission fault, and the malicious fault. Now, in case of crash fault, the processor stops functioning and it never resumes its operation. As far as the omission fault is concerned, the processor is going to omit, processor omits to send a message to some processors, and the processor which is sent according to the protocol or the algorithm, whatever it is executing. So a processor is supposed to broadcast it. For example, what is the meaning of omission fault? that the processor is supposed to broadcast a message to all the processor, but it sends the message only to the few processors. So it may be possible that it is required to broadcast the message to all processors, but it is able to send only to the few processors. So this kind of fault, is called omission fault. In the third kind of fault, that is called the malicious fault, in which the processors used to behaves randomly. Either it will be sending or it will be not sending. It will be sending the information or the messages just for the confusing other processors. So it has very broad nature as far as the malicious faults are concerned, and it is the most conceivable faults that are treated as the malicious fault. And these malicious faults are also called the Byzantine fault. Now, as far as the faulty processor are concerned, the faulty processor can refuse to send a message to a non-faulty processor, and never receive an expected message from the faulty processors. In such situation, we assume that the non-faulty processor simply choose the arbitrary value or acts that it is expected. Whatever it has expected, it has received it. Let us go to the next, which is the authenticated versus the non-authenticated messages. Now, in order to reach a particular agreement, the processor have to exchange certain values, and values as well as the relay of the received values to the other processors, and it has to be done several times. Now, as far as the capability is concerned, the capability of the faulty processors, it's going to distort that whatever they have received from the other processor, and it depends upon the messages which they are going to receive. So there are two kinds of the messages. One is authenticated message, and another is the non-authenticated one. In the authenticated message, the processor cannot forge a message, or it cannot change the content of the received message before it is going to relay the message to the other processors. So whatever it has received, it has to be sent as it is. So in this particular case, the processor can verify the authenticity of the received message, and this kind of authenticated message is also called the signed message. Now, in unauthenticated message system, the processor can forge or it can change the content before it is going to relay the message to the other processors. So a processor has no way to verify that about the authenticity of the received message, and the kind of the message which is sent by the processor is known as the oral message. So as far as the agreement is concerned, it is easier to reach the agreement in an authenticated message system, but because the presence of the faulty processor, because the presence of the faulty processor, which has the capability of doing the less damages, because the non-faulty processors are not going to damage anything, but the faulty processor are going to damage the things. Now, we have certain classification of the agreement problem, and we have three kinds of the agreement problem. Three well-known agreement problem in the distributed system: the Byzantine agreement problem, the consensus problem, and the interactive consistency problem. Now, in the Byzantine agreement problem, we assume single value, and this single value, which is on this single value, there is an agreement which is going to happen in between the processors, and this initial value or the single value is initialized by an arbitrary processor, and all the non-faulty processor have to agree on that particular value, whatever is being sent by the source processor. Now, as far as the consensus problem is concerned, so in Byzantine agreement problem, there is only one value, single value, on which there is an agreement in between the all processors. And this value is being initialized or initiated by the source processor, and it is being sent to the all processors. But in case of consensus problem, every processor is going to initialize its own value. So every processor has its own initial value, and all the non-faulty processor have to agree on this one single common value. But in case of interactive consistency problem, we have every processor has its initial value, and all the non-faulty processor must have to be agreed on a set of common value. So we have three kinds of the problem. In one problem, single value is being assumed and single value on which the agreement is being focused. Single value is initialized by the source processor. In consensus problem, every processor is going to initialize value, and then all the non-faulty processors are going to make an agreement on a one common value. But in interactive consistency problem, all the processors are initializing its own value, initial value, and every processor have to be agreed on a certain set of the common value. So there are certain common agreement. Of course, in Byzantine problem, the common agreement on the single value. Consensus problem, we have a common agreement on the single value. Interactive consistency, we have a common agreement on the certain set of the common value. In Byzantine, only one processor is going to initialize the process. In consensus, all the processors are going to initialize the process, but only one value is taken in the form of agreement. In interactive consistency, all the processors are initializing the value, and set of those values, common values, are considered, are taken into the consideration. So let us first discuss about the Byzantine agreement problem. In Byzantine agreement problem, any arbitrary chosen processor called the source processor, it is going to broadcast its initial value to all the processors. And the solution of this kind of agreement problem should should met these two objectives. First is the agreement, second is the validity. Now, what is the agreement? That all non-faulty processors agree on the same value, whatever value which is being initialized and sent by the source processor. So all the non-faulty processors, those processors which are faulty are not required to be agreed on that, but all non-faulty processors have to be agreed on the same value, which is sent by the initial value from the source processor. And the validity is the second aspect or the second objective, in which if the processor is non-faulty, then the common agreed upon value by all non-faulty processor should be the initial value of the source. Meaning thereby, if the source processor has sent some initial value to all non-faulty processors, and the processors who are non-faulty, then they have to be agreed on the value, which have to agree, all the non-faulty processor have to be agreed on that particular value, which is the initial value which has been sent by the source processor. But here two things are very important. The first thing is that if the source processor is faulty, if the source which is sending its initial value, if it is faulty, then all non-faulty processor can agree on the common value. It is the responsibility of the rest of the non-faulty processor to be on an agreement on a common value. And it is irrelevant what value faulty processor agrees on. Whatever faulty, if there is a processor which is faulty, it is irrelevant that whatever value it is going to be agree on, or whether they agree on a value or not at all. Whether they are going to be agree on value, because these are the faulty processors. So faulty processors are not taken into the consideration. Only the non-faulty processor have to become into a common agreement. Now, as far as the consensus problem is concerned, every processor broadcasts, as told you earlier, that it is going to broadcast its initial value, and initial values of the processor may be different. It is not necessary that every processor who is going to broadcast its initial value are same. They may be different. So what kind of agreement? We have again two objectives in the consensus problem also, that all non-faulty processor agree on the same single value. Whatever initial value has been broadcasted by the rest of the processor, they have all non-faulty processor have to be agreed on a single common value, same value. And what is about the second objective is the validity. If the initial value of every non-faulty processor is V, then the agreed common value by all non-faulty processor must be V. That's all. So meaning thereby, whatever value they are initializing, they have to be on coming on a consensus on a single value. And if all the initial values broadcasted by non-faulty processors are V, then they must have a agreed common value of V. If the initial value of all the non-faulty processors are different, then all non-faulty processors have to be agreed on any common value. So this validity is related with if in the case when the initial values are same. But if the initial values are different, they have to be agreed that suppose there are five processor, one is sending one, another is sending two, another is sending one, fourth is sending one, fifth is sending two. So there are 3 ones which are coming and 2 twos are coming. So they have to agree on a common value. Either they should select 1 or they should select 2. Either they should select 0 or they should select 1, whatever. But they have to be in consensus. They have to choose only one value as the common value. Now, in interactive consistency problem, every processor broadcasts its initial value, and this initial value may be different. Now, what is the agreement? The first objective of this problem is all non-faulty processors agree on the same vector. As I told you that in this particular case, interactive consistency problem, instead of coming on the agreement on a single value, but instead of that, we come into the agreement of the set of the values, that is V1, V2 up to Vn. And the validity is concerned if the ith processor is non-faulty and its initialization value is Vi, then the ith value to be agreed on by all non-faulty processor must be Vi. If Vi is the value which is given by the ith processor, then the ith value to be agreed on, whatever is processor which is ith processor, इसकी किसी भी value पे अगर agree होना है, that will be the Vi. Now, if the jth processor is faulty, now in that case, if suppose jth processor is faulty, then all non-faulty processor can agree on any common value for Vj. It is not necessary that it should be Vj. It can be any value of Vj. Why? Because this jth processor is going to become faulty. So it is irrelevant that whatever the value is concerned with the faulty processor, it is going to be agreed on or not. It is immaterial. So we have a solution of the Byzantine agreement problem, and this as far as the solution of the Byzantine agreement problem is concerned, this was first taken care by the Lamport under the processor failure condition, because the agreement, as I told you, agreement protocol is required whether the process is going to fail or the channel is going to fail. Since we are discussing about the processor failure only, so the first defined and solved problem has been solution of the problem has been given by the Lamport. And in this problem, any arbitrary chosen processor, which is called the source processor, broadcast its initial value to the rest of the processors, to the all processors, and a protocol for the Byzantine algorithm agreement, it is going to give the guarantee that all the non-faulty processors are going to agree on the same value, and if the source processor is non-faulty, then the common agreed value by all non-faulty processor should be the initial value of the source. If the source processor is non-faulty, all the non-faulty processor, rest of the non-faulty processor, they must agree on one common value, and that value is the initial value which the source processor has set. Now, it is also obvious that all the processors are going to exchange the values through the messages to reach a consensus, and the processors send these values, their values, to the other processor, and that sending of the messages are called the relay, and the relay which is being received values to the other processors are going to become the same which they have received from the source processor. Now, as far as the execution of the protocol is concerned, during the execution of the protocol, the faulty processors may be able to confuse the other non-faulty processors by sending the conflicting message, by sending spurious messages, so that, or by relaying them with the fictitious value. So this can happen. But as far as the implementation of this Lamport's algorithm is concerned on the Byzantine, for finding the solution of the Byzantine algorithm, Byzantine agreement problem, they have showed that, of course, the algorithm is not only given by Lamport, it is the collection of three people, Lamport, Shastok, and Pease algorithm, which is going to give the solution about the Byzantine agreement problem. And they have declared that it is impossible to reach to a common consensus if the number of faulty processors, where m is the number of faulty processor, exceeds the truncation of n minus 1 by 3, where n is the total number of the processes. Of course, this value, this is truncation, this is a whole bracket, but this is the truncation sign, that n minus 1, if the number of faulty processors are going to become more than n minus 1 by 3, then it will be very difficult, or it will be impossible to reach up to a common consensus. So, so we will be discussing this impossibility result, because still we have not declared, we are not going to discuss about the Lamport Shastok Pease algorithm, but what we are going to discuss with an example, that Byzantine problem can be reached to this problem have the solution for the three processors or not. And in that particular case, one first case is being discussed, and the first case says that P0 is non-faulty and P2 is but faulty, because the indication of the non-faulty processor is through the circle, and non-faulty processor is represented in the form of a oval. So it is assumed that P2 is a faulty processor, and P0 and P1 is a non-faulty processor, and suppose P0 is the source processor, and it is going to broadcast an initial value 1 to both P1 and P2. Now processor P2, which is acting as a malicious or the faulty processor, and it is going to communicate a value 0 to the non-faulty processor P1. Thus, P1 is going to receive 1 from the processor P0, and it is going to receive 0 from the P1 from the P2, because P2 is a faulty processor. Of course, if this processor is a non-faulty processor, then whatever value it has received, this has to be sent by the P2 to the P1. But since it is a faulty processor, it is not sending 1, it is sending a malicious communication, doing malicious communication through sending 0. So whenever P1 is going to receive 1 from P0 and 0 from P2, so it is going to conflict, because agreement is not able to be done. So a fault. So what happens, that P1 is going to depict that P2 is faulty, because it is receiving 1 and it is receiving 0 from P2. So it is depicting that P2 is somehow faulty. But since P1 has received 1 from, so once it detects that P2 is faulty, so it accepts the value of 1. P0 accepts the value 1. And if it is going to accept the value 1, so it is going to satisfy the first condition, that is the condition which is the second condition, that is if the source processor is non-faulty, then the processor common agreed upon the value by all non-faulty processors should be the initial value of the source. So P1 is going to be agreed on 1. Of course, since P2 is a faulty, whether it is going to agreed on 1 or not, it is immaterial. So in this case, the condition is going to be satisfied for the Byzantine problem. Now, if we take the case of second case in which P0 is faulty, means the source processor is faulty. Now, suppose the source processor is faulty and P0 is sending 1 to P1 and 0 to P2. So processor P2 now communicates to P1. Since it has received 0, so as it is, it has sent 0. So it is satisfying the condition number 1, that the processor is sending those values to which it has received as in the form of a initial value. Now, as far as the processor P1 is concerned, uh, it will it will be in dilemma, because it has received 1 from this and it has received 0 from this. So it is unable to distinguish on which value it is going to agree, whether it will going to agree on 1 or it is going to agree on 0. Because the first condition says that the whatever it has to be agreed on the in source value, and second condition says that whatever value P2 has received, it has sent it as it is. So using a similar argument, now we can show that P2 is going to receive 1 because P1 has received 1. So P2 is going to receive 1. But P2 has received 0, so it has sent 0 to the other. So even if P1 communicates a value 1 to the P2, it is going to satisfy the condition number 2, but it is very difficult to agree P1 P2 about 1 or the 0. So it means there is no solution which is existing for a Byzantine problem, because in case of 3 processor, because for 3 processor it is not able to work, it is going to fail. So this is about the impossibility result.